You're going to be seeing this a lot. You're going to be hearing Marco Durante's name a lot, and this is why.
Radiation. We are all scared of radiation. But radiation in space is heavy ions, iron, these exotic particles, very heavy, very densely ionizing. We say this is a beautiful image that you see. What you see here, this one, is a human cell. This is a human nucleus, it's 10 microns approximately. And these two lines that you see here are two iron ions that you don't find in space.
Not long duration.
You find in space, but not on Earth, except in Darmstadt and GSI.
Not on Earth.
We have it. Going through the cells and making damage to the DNA. You will not solve the problem using passive shielding. You can think of active shielding. You can think of electrostatic shielding. I mean, some kind of electrostatic spheres that protect the astronauts.
So NASA responded, of course, with this.
To every astronaut or spacecraft, the sun is a damaging source of radiation. All objects traveling through space must contend with this hazard, including planets. Even the moon has the scars to prove it. New NASA research suggests that some of the coloration we see on the moon could actually be a form of sunburn.
The leading hypothesis is that the magnetic fields are blocking some portion of the solar wind from reaching the surface.
The solar wind is the sun's continuous outflow of particles and radiation that fills the inner solar system. Fortunately, the moon's patches of magnetic field are not robust enough to completely protect human explorers from the sun's radiation. But further study of lunar magnetic fields could lay the groundwork for future innovations.
Well, what if we got a strong enough magnetic field that perhaps we could produce artificially? That's a question that I think remains to be answered, but the crustal magnetic fields on the moon and lunar swirls kind of provide a hint in that direction that we might be able to learn something about.
From NASA themselves. This is the video you just watched. It's on NASA's YouTube channel. They use to upload videos onto their .gov website and their social media accounts. This is them saying it. You just watched the world's leading particle physicist, Marco Durante, tell them what they needed. And for the last 5 years, they've been working on that. 8 months ago, they figured out there's other anomalies out there that might be able to assist them in figuring this out. They sent out the Parker probe, which is going just above the exosphere, 6,213 miles up, to touch one of the raw particles Marco Durante just showed we'll be exposed to. Now, here is NASA once again stating that Michael Collins and Apollo would need active shielding to leave the thermosphere, and that we might, because of heavy solar storms, be able to create vests and passive shielding that will assist them in the lower thermosphere, but you need active shielding, like shown in the last two clips, to leave Earth's magnetosphere.
But in transit, astronauts can only be protected with what's on the spacecraft.
Which means that you might have elements on a spacecraft that have multiple purposes.
NASA's space radiation specialists are testing different ways to do this. One strategy they tested on the Orion spacecraft involves crew members barricading themselves with as much mass as possible in the center of the spacecraft.
International Space Station height.
Other possible techniques in development include vests that add mass and electrically charged surfaces that deflect particles.
They just said it again. Over and over and over. Every single time they create a new video, all they're doing is talking about how passive shielding and these transitional metals and various polymers, hydrogen-based solutions, they could work for within low Earth orbit. So International Space Station, that's going to have this stuff right here. You need to have what NASA is now saying is electromagnetic shielding. They just launched these vests yesterday. This was 2 months ago. Yesterday they launched these vests that they just now created to the International Space Station to test them out so they don't have to use all of the stuff around them to pile on top of them. They might be able to save all of their internal organs with these new vests. This only gets us safe at 230 miles up. You need this to go higher in the thermosphere. Apollo didn't have this. They didn't go higher in the thermosphere. NASA said it again. However, now all the social media sites are going to say it. You ready?
But we can try to build an external magnetic shield. The easiest would be to do that in space, an orbiting field generator placed between Mars and the Sun, like a giant space umbrella. The resources and energy needed to build this is insane.
If we could block the solar wind from stripping away the atmosphere, it might start to build back up again. At first that might sound like it involves building something the size of a planet, and that's not super practical, but the researchers proposed a way to get around that problem by taking advantage of the fact that the solar wind is only coming from one direction, the sun. So all we would need to do is block the sun. Kind of like what the moon does during an eclipse, which would still require a huge shield, but we wouldn't have to build a giant solid thing.
Jupiter would
just
be radiating it too.
And that might actually be practical someday. All we would have to do is figure out how to generate the field. Then it would reach out into space and do the rest. More specifically, the team suggested putting a field generator.
There it is. Jim Green. So once again, here is NASA saying all we have to do to leave Earth's magnetosphere, or to be somewhere that doesn't have a magnetosphere, is create a magnetosphere.
Another thing we typically take for granted here on Earth is that most radiation from deep space glances off the Earth's magnetic field and leaves us alone. Even out on the ISS, astronauts are mostly protected by this shield. But once we start breaking out of that protective zone on a journey to Mars, radiation is no joke. Months or years it would take to get to and from Mars. And so far, it looks pretty gnarly. Recent research on mice suggests that chronic low-dose rate neutron radiation, like the kind people would encounter on a journey to Mars, actually slows down signals between neurons. The mice in this study developed problems with learning and memory and showed signs of distress. This suggests that radiation would be super dangerous for astronauts who'd be in pretty bad neurological shape by the time they got to Mars. Shielding space radiation is tricky though. Research is going to have to focus on developing super effective shielding if we want our astronauts to be functional once they reach Mars. Right now, NASA is exploring shields with high amounts of hydrogen or boron, which are...
Remember, that's what all of the shielding for the International Space Station uses, and you need active shielding, a giant magnetosphere, to be around the craft to deflect everything, as that will only stop what it didn't deflect.
Particularly effective at blocking radioactive particles. And if engineers can design a system that generates enough power, we might one day be able to create magnetic force fields around spaceships that direct radiation, just like Earth's magnetic field. Right now, though, we're still looking for the right solution.
An explosion at a remote site. Shifting stories from the Russian government and nuclear officials. Public concern about radiation exposure. We're not talking about Chernobyl 33 years ago. We're talking about 2 Russian military accidents near the Arctic Circle, one just last week.
A couple months ago, the rest of the world united with Russia in trying to create a nuclear device that would be small enough and capable of producing enough power that they could put it on a conventional liquid propulsion rocket. The reason for doing this is it will be able to create active shielding, as that is all we need to actually leave the thermosphere, because without that, you can't actually leave the magnetosphere.
So at the end, shall we go to Mars or not? Well, I think I was supposed to give ideas here. It looks like, radiation is a problem. This is clear. Shielding, passive shielding can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shield, is to build magnetic fields for the spacecrafts that can do what is done on Earth. So it's not really a new idea. It's the same idea that God had a few billions of years ago when he said, okay, I want to make life, but I created radiation already. What can I do now?